Okay, so continuing to look at graphing trigonometric functions and sticking with just the sine function for now, we're going to talk about different ways that you can actually transform that basic sine graph. Even though you're transforming it, it's still basically the same shape. Just like every parabola is basically the same parabola, and it's just as easy to draw a parabola and then instead of graphing it, just label everything correctly. I always think it's easier just to draw a sine wave and then just label everything, which is probably what we'll end up doing here. So let's just go ahead, and we know that this thing is basically going to look like a sine wave. So let's just draw a sine wave. Okay. Now, we don't know what these numbers are, but we can talk about what effect they're going to have on this graph. So let's start with the A because it's the simplest. A, and easy enough to remember, is going to be your amplitude. And it's actually going to be this distance from the midline to the peak of the sine wave. And so if A is 3, then this distance is going to be 3. If there is no A, implying that your multiplier is 1, then of course it's going to go positive 1 to negative 1. If A is 5, you're going to go up to positive 5 and down to negative 5. So that's easy enough to label. We can just say that this is now A, and this down here is going to be negative A relative to this middle line. Okay. Sine, basically just that's our parent function, so we know what it's going to look like. B directly affects this period. In other words, how long does it take, or how quickly does it take to go through one complete cycle? And the way to get this is basically take the B value and divide it into the normal period. So the normal period of sine is 2 pi. So if you just take that B value, then this is going to be your new period, which tells you the distance from here to here. Can't really read that, but you know what I'm talking about. That's the period from here to here. So now you know this distance. Okay? Now, we want to know where we're starting, right? And this could be the y-axis, but it may not. And it depends on this value of c. Now, it's not directly c. It is if there's no real b value, or at least if the b is a 1. Then you can look at c and say, oh, that's my phase shift. Just exactly like a parabola in vertex form. It shifts it right if it's negative and left if it's positive. The better way to look at this is your phase shift is going to be your c divided by b. So how much this point here, where you start, moves left or right of the y-axis, that's determined by your phase shift. Another way to look at this, and let's do it right here, is I've got this b minus c. And if you think of this as essentially what you're going to be evaluating in the sine function, b times this angle minus c, and you know that the period runs, the normal sine period, runs from 0 to 360. We'll just use degrees. Then if you simply solve for the theta in this equation, you're going to get a lot of this information kind of done for you, which I kind of like this method. So if we add the c to both sides, so notice how we've literally shifted to this whole thing to the right by c, but now we have to divide out the b. So we end up with a c divided by b is our starting point. It's the new point here, so this becomes c divided by b. And then this becomes theta. And this becomes 360 plus c divided by b, and that's what this point is right here. So now you found the beginning and the ending of this first period. You can find this midpoint just by finding the midpoint of those 2 points. Easy enough, just add them together, divide by 2. You can do the same thing here to find this point, same thing here to find this point. Makes graphing this really, really easy. And all that leaves is this d value. And if you've done many transformations of any kind of graph, you can probably anticipate that the d simply changes this center line. It's what moves it up or down the y-axis and just shifts the whole thing up or down. About the only other thing you can do is say, well, if a is negative, then just think about starting off with an inverted graph, one that goes down, then comes back up. Everything else will be the same. And you can calculate your period, your phase shift, and your vertical shift all from there. So this form of the equation includes all the possible transformations that we're going to see while we're studying trig functions in this class. And that's really all there is to it. Now, substitute that for a cosine. We just changed the parent function a little bit. It still looks the same, but it's really just a sine wave that's already phase shifted a little bit. Same period. If you're working with a tangent or a cotangent, then you're going to put 180 down here because the initial period is 180. Cotangent starts and stops at a different point. We'll just keep those things in mind. That just once you start with a parent function, all these transformations work in tandem to make life easy for you. So in the next lesson, we'll actually take some actual values. We'll calculate the amplitude, phase shift, and period. Usually when you're graphing trigonometric functions, you're generally asked to answer those questions specifically. What is the period? What is the amplitude? And what is the phase shift? And then go ahead and note those things on the graph. And like I said, you just take any sine wave and put the labels on, and it's going to be accurate. So there you go.